Good day, perpetualites! Today, we will be introducing to you the different types of separating mixture. But first, let us define what is separating mixture is. Separating mixture is a fundamental concept in chemistry that involves isolating individual components of a mixture, which is the combination of two or more substances that are physically combined but not chemically bonded. A mixture can be defined as homogeneous and heterogeneous. The separating process depends on the physical properties of a component, such as size, particle, solubility, density, and boiling point. Now we're done defining what is separating mixture is. Now let's move on to the 4 types of separating mixture: the filtration, distillation, evaporation, and sieving.
That is right! Thank you, Dane. As what she just said, in this video, us, the Group 1, will demonstrate and explain the methods of separating mixtures, mainly evaporation, decantation, sieving, and filtration. Let us begin with Daphne's demonstration of filtration.
In this video, filtration is being illustrated. In filtration, particles making up the substances in the mixture are separated based on their size. For example, is this video. A tissue can be used to separate out the larger components, dirt or stone, of soil from the finer ones. Therefore, it shows that filtration separates solids particles from liquid using a barrier.
What is sieving? Sieving is a mechanical process used to separate particles of different sizes from a mixture. What are the examples of sieving? 1. Sifting soil, separating soil and rocks. Construction projects sometimes require soil to be sifted to remove rocks or debris before using it for landscaping or other purposes. 2. Straining powders. When using ingredients like powdered sugar, cocoa powder, or cornstarch, sieving helps remove any clumps, allowing for a more even mixture in recipes. I will show you a demonstration in separating using rice and salt.
Step 1. Use a sieve with holes that are small enough to allow the salt crystals to pass through but large enough to keep the rice grains on top. This ensures that only the finer salt particles fall through the sieve. Step 2. Place the rice-salt mixture into the sieve. Shake the sieve gently. The salt, being smaller, will pass through the sieve and collect in a container below, while the rice will stay on top. Lastly, after sieving, you will have salt in the container that passed through the sieve and rice that remains in the sieve. Rice is separated by staying in the sieve. Salt is separated by falling through the sieve. This method works as long as the salt particles are significantly smaller than the rice grains.
What is decantation? Decantation is the process of separation of liquid from solid and other immiscible non-mixing liquids by removing the liquid layer at the top from the layer of solid or liquid below. How does decantation work? The solid particles settle down at the bottom due to gravity, forming a sediment, while the liquid remains on top. The clear liquid supernatant is carefully poured off or siphoned from the top, leaving the sediment behind.
Example, separating sand and water. 1. Mixture. Imagine a breaker with a mixture of sand and water. The sand is denser than the water and will settle to the bottom of the breaker after allowing the mixture to stand undisturbed for a while. 2. Decantation process. After the sand settles at the bottom, you can carefully pour the water into another container, leaving the sand behind. 3. The sand remains in the original container, separated from the water, because it is heavier and sinks.
Now I'll show you a demonstration by separating soil and water.
Today, in this video, I'm going to demonstrate the process of evaporation as a method of separating salt and water. Evaporation is a natural phenomenon that plays a crucial role in various scientific and everyday applications. For example here, in the case of salt and water, evaporation occurs when the water starts to boil, leaving the salt behind as it continues to evaporate.
Bien will demonstrate how he evaporated the salt and water solution. And it will be explained by me. So first, we are going to do our mixture. We have here water and then put enough salt into the water. And then mix it until the salt dissolves into the water. So now we have a homogeneous mixture, salt and water solution. Now, what are we going to do to separate the salt from the water? We have to do an evaporation method for us to separate these two. And how are we going to do that? We have to boil it. We are going to separate salt from the water through evaporation. The evaporation starts when water reaches the boiling point at 100 degrees Celsius. Take an observation. Look at the edges. You can now see a little bit of salt and some of the water is all ready and starts to evaporate. Okay, let's wait again. As you can see here, the water is gradually diminishing and we can now see more salt than before. We're almost there. Look at the edges. We can now see salt more clearly. I think all of the water has already evaporated. Let's wait a bit more. Yeah, we're done. It's already evaporated. The one who will be left behind is the salt. And that's how to separate salt from water through evaporation. Now it's all dried up. We can now turn off the stove. You see, that's it. That's how to separate this mixture using the evaporation method. And that concludes our video demonstration. I hope you learned a lot and you enjoyed watching. Again, this is Group 1. Thank you very much.